This conference will now be recorded.
Okay. Um, Good evening, friends. So in today's session, we are basically focusing on Databricks job execution hierarchy. So, when you submit any application in the Databricks, we know mostly in the Databricks, we are going to use the Databricks notebooks to submit our application code. That is nothing but we are not executing as application. Instead, we are executing our Spark code as a interactive notebooks. So whenever you submit a particular cell, that is going and submitting as a one application. So now what happens is there is a notebook. In that notebook, if I have a 20 commands, so in first command when I submitted, what happens? One application will be created. Under that application, it also creates the jobs. Under jobs, it creates the stages. Under stages, it creates the tasks. So in the task, so we can execute a one partition per task or four partitions per task. We can able to execute. So optimized way to execute is one partition per task or four partitions per task, but more than four or less than one is not suggested or not recommended. Okay, so today we will understand when you submit the commands one by one in the Databricks notebooks, how the execution is going to happen in the background. What is the lazy evaluation? Suppose I have written some code. So from the code, how to understand how many jobs are going to create. So under the jobs, how many stages are going to create, how many tasks are going to create, how to check all these things, everything we are going to look at today. Okay, so Databricks execution hierarchy, as you know. So first, when you submit any comment in the from the Databricks notebook, or you can execute entire Python file, or you can execute a jar file. So everything will be treated as a application. So in the application, first you will have a jobs. Okay, jobs, multiple jobs will be created. So we will write some code today and we will see how many jobs it can create. We are going to understand. Okay, so when you submit an application, it's going to create the multiple jobs. How, when it will create two jobs, when it will create three jobs, when it will create only one job, that particular thing we are going to understand today. So inside job, we know what it will create. Any idea? We know, right?
Yes.
Viewers. So what it will create? Stages. So stages. Okay, so basically the job can create a stages. So how many stages we can have under a job? Under a job, how many stages we can have? One or more. Remember, minimum one or more than one also we may have. Under stage, what we will have? We will have a task. So task is basically based on the number of cores, those many tasks it will launch. Or what happens is, if we have a two cores, and if I have a 8 partitions, what happens is four partitions it will execute on a one core. So that's why I said per core, what is the suggested number of partitions we can execute is one partition per core, or four partitions per core we can able to execute to get a better performance. Now, what is a task here? Task is nothing but not the number of core. If I have a two cores, it's a two task. No, task is nothing but the number of partitions that you have. If you have created the two partitions, so two partitions is nothing but two tasks are going to run in the stage. Okay, if I have a 8 partitions, I read a one, let's say 1 lakh records I read, and it is created a 8 partitions. It divided 1 lakh records into the 8 partitions. Now what happens? How many tasks I can have? 8 partitions. If I have means,
Eight
how many
tasks.
tasks it will launch? 8 tasks it will launch. Each partition execution is nothing but a one task. When new stage will be created, we already discussed as part of the training. Everybody's forgot. You all are new, not new to Databricks, right? We already completed our training. When new stage will get created? Yesterday also we discussed, I think.
When
New
shuffle
stage will
happens, new stage will be created.
exactly. When there is a shuffling happened, then new stage will get created. When the shuffling will happen, when shuffling will happen.
In case of white transformation,
Very good. In case of Y transformation, what are the example of Y transformation? So group by, join, all the reduce by, all these are a example for the Y transformation. Let me give you simple example. I have a 4 people. Okay, I have a 4 people. So 1, 2, 3, 4. People name is 1, 2, 3, 4. Simple understanding. Okay, there are 4 people. What I have done is I have given a 3 different chocolates to each person. For first person I have given red, white, orange. For second person also I have given red, orange, and whatever white. Okay, again third person also same three types of chocolates. Fourth person also have given 3 types of chocolates I have given. Clear to all of you? Now what happens per person? How many chocolates we have? Let me just take a paint and show you. Let's consider there are 4 people I have. Okay, so there are 4 people. Otherwise, let me simply take it like this. There are 4 people. So he is the first person, he is the second person, he is the third person, he is the fourth person. Okay, I have a 4 people. Now what happened is in these 4 people, I have kept 4 different chocolates. How many types of chocolates? 4 different chocolates or 3 different chocolates. So you can say white, red, orange, yellow, something like this. You can able to say, okay. Or if you want to say one more, white, red, white, red, orange, yellow, and what else is there? Something blue. Okay, so 5 chocolates I have given to this person, and 5 chocolates I have given to this person. 5 chocolates. Okay, 5 chocolates I am giving to this person. 5 chocolates I have given to this person. Okay, okay, good. Now careful observe white, red, orange, yellow, blue. So there are 5 different chocolates everybody is having. Now what I want to do is I don't want a blue chocolate. So I want to filter out. I want to filter out the blue chocolates from everybody. So this person, what he will do, he will just give all these things. When he is giving that, basically he just read the data. Okay, he just read the data here. He just received the chocolates. Now I said, same person, I said, can you remove the blue chocolate? Can you just throw outside this blue chocolate? Can you just throw outside? I said that is not required for me. What I said is, so don't select blue chocolate. Chocolate should not be equal to blue, I said. Meaning, so what happens is it will give you all other chocolates except what? Except what? Blue chocolate. Clear? So now everybody is going to have what? Carefully observe. Everybody is going to have what? What everybody will have? Why you are
Except
not
blue remaining all.
Yes. So except blue, remaining all, everybody is going to have. Agree? Okay.
yes.
Now can you tell me what type of transformation this is?
Narrow transformation.
Narrow transformation. What is meant by narrow transformation?
Shuffle won't happen.
Shuffle is not happening, right? See, simply this person is given the chocolates to just this person itself has filtered out. He is not moving the chocolate to here. He is not giving chocolate to somebody else, meaning he is not giving this chocolate to other mission. Okay, so basically what is happening here is he is just filtering out, he is just throwing out that particular chocolate, he is ignoring that particular chocolate and he is taking other chocolates. This is a narrow transformation, meaning whatever chocolates he has same chocolates here also. He just removed this particular chocolate, but he is not giving this chocolate, he is not sending this particular chocolate from this person to second person. No, first person to second person any chocolate is going? No, From first person to third person, any chocolate is going? No. From first person, any chocolate is going to fourth person? No. Meaning no chocolates are moving from this particular, like first person is having whatever chocolates he is having same chocolates. He just ignored one of the chocolate, but he did not send any of this chocolate to other people. Okay, clear? Everybody is clear? This is a narrow transformation. When you will say narrow transformation is if the record is not moving to the another computer, if the record is not moving to the another computer, the record is same, it is there in the same mission, there is no movement in the data. So data is going from same system to same system, but this record, this data is not moving from one computer to another computer. Just consider, instead of 1 2 3 4 people, consider as a 4 computers. 4 computers is having 5 different records: white record, red record, orange record, yellow record, and blue record. So I don't want blue record, I just ignored. I have taken only white, red, orange, and yellow records into my consideration. Okay, so but I have not moved. So when you are doing these kind of processes, what happens, the processing will be very faster, and within the same stage everything will be computed. What is the other case? White transformation. What is meant by white transformation? What is meant by white transformation?
Shuffle will be happen.
So in this example, what we can do is we can say group by color. So somebody applied a function called group by color. Group by color. When you say group by color, what happens? When you say group by color, what is going to happen? So all the chocolates, example, this person, what he will do, he will keep only whites. Okay, white chocolates, this person is interested, so he will keep only white chocolates. What about this person? This person will like keep only red chocolates. This person will keep only orange chocolates. This person will keep only yellow chocolates. Now he is having white chocolate, so he will send red chocolate to here, orange chocolate to here, yellow chocolate to here. Okay, so this person, white chocolate, he will send it here, red chocolate will move to same mission, orange chocolate will be here, yellow chocolate will come here, white again will move to here, red will come to here, orange will come to here, yellow will come to here. Again, white will move here, orange will move here, sorry, red will move there, orange will come here, yellow will come here. Now how many whites are there? 4. How many reds are there? 4. How many oranges are there? 4. How many yellows are there? 4. So meaning whenever you are doing aggregations, like this, you must have to combine. So can you just tell me total employees in a department? So you must do group by department, then only you will get the employee count of employees. If you want to get it, you must do a group by department. Similarly here I just did group by color. When I say group by color, all the colors will come into a one mission, all remaining colors will go to this mission, all orange comes to this mission, all yellow will come to this mission. Now some people will ask, because normally everybody will have doubt, right? Sir, what happens if I have a one more item here? Blue also, I brought it by default. Now I have blue also. In which mission this blue color item will be there? So remember, if we have a limited resources, what happens is two items will be accumulated or like collected at a same mission. Like maybe white and blue may be collected at a same mission. White and blue is collected at a same mission. Maybe some other things, red and orange is collected at here only. Orange and yellow is corrected, maybe collected here only. So we don't know. If you have a more items, then multiple items will be collected. But ultimately, there is no chance that some whites will be here, few more white color chocolates will be here. No, that will not happen, because the purpose of group by means all the similar color items you need to group it into a single place. So when you are bringing all the white chocolates to a single mission, what is going to happen is it is basically move all the whites into a one mission, all the reds into another mission, all yellow into another mission, and so on. So this is a white transformation. When this white transformation happened, what happens is whatever data we have earlier in this mission, whatever data we have in this mission now, both are different. When there is a change in the data that mission contains, then what happens? Above everything will form a one stage. above all these things will create a one stage, all below will create a one more stage. So in this case what happens, two stages are going to create. Until the narrow transformation there won't be any new stage. Whenever there is a wide transformation like this happens, new stage will get created. Clear or any questions? Everybody understood? Who is not understand still, let me know so that I can help you. I'll try to explain in different way. See, if you people are silent, I am not able to understand whether you are understanding, you are not understanding.
Malia, when the stage gets divided into tasks, at what point multiple tasks will be created?
Okay, very good question. That part in detail we will discuss tomorrow, but let me explain here. So there are some configuration. Okay, so task wise we need to discuss today. Partition wise we will discuss. Partition concept we will discuss in detail tomorrow. Let me explain here. What happens is, after, let's say here, by default Spark will divide the data into 200 partitions. Okay, that is the expectation. If you have a good cluster, it will try to create a 200 partition, and the expected partition size is 200 MB. Less than 200 MB is expected. The reason is, if you have a partition size 200 MB and if you have a 200 partitions, okay, so that will give you good performance. See, don't talk about 2 GB data, 5 GB data. We need to talk about like hundreds of GBs of data. When you have hundreds of GBs of data, we will take 200 partitions. Partition size is 200 MB, something like that. We need to optimize it. So if the partition size is less than 2 MB, 200 into 200, it will go for 2 2 4 40,000. 40,000 means how much? 40 GB, right? Yeah, 40 GB. Okay, so now if the data is 80 GB of data, then you make it as a 400 partitions. By default, what happens is, there is a Spark configuration which will set the Spark default partitions to 200, but you can change those things. When it will create 200 is if you have a large amount of data. So now example, now I am going to show you some Databricks example, some coding. In that coding, I just have taken some 1 lakh records, 1,30,000 records, 10 lakhs records, small few columns with a small amount of data I have taken. So in that case, what happens? It may create a 2 partitions or 3 partition or 8 partition. If I have taken a 10 lakhs records, it may create 8 partitions, something like that it will create. But in real time, you are going to handle with the GBs of data, hundreds of GBs of data. At that time, make sure that partition size is less than or equal to 200 MB, and try to make partitions. Based on that, you can adjust the partitions. Okay, it may be 200 by default. Partition number will be set it to 200, but you can change that number using this, like spark.sql.shuffle.partitions. There is a property. Using that property, you can able to adjust the number of partitions. Clear? So now here, when it comes to here, what happens? How many partitions it will create is based on the data volume. Based on the data volume, it may create the multiple partitions. Okay, example. So I have some data and it is created 2 partitions. It created 2 partitions. When it is created 2 partitions, if you have a 2 cores, one partition will execute on a 1 core. One partition will execute on a 1 core. Let's say we have a 3 partitions. So this is not recommended. When you have a 2 cores, it must be 2 or 4. It should not be a 3. Why it is not recommended to have a 3? Tell me.
Maybe uneven distribution will happen.
Not uneven distribution, that is different concept. Okay,
Skewness
so
will
what
happen.
happens is, no, skewness, uneven distribution, both are same. Okay, so now what happens if you have 3 partitions and 2 courses? Carefully observe. So 2 cores are there. Okay, 1 and 2, there are 2 cores. Now you have 3 partitions. Okay, we have 3 partitions. Now what happens is, first partition I submitted on this, second partition I submitted on this. Both are working parallelly. Now both course got completed. The execution is completed. Now what happens? I have how many more partitions?
No.
Huh?
One more.
One more. So one more, if you submit on this is going to be ID, meaning you are not using. So till the time this partition executed from this core, this particular core is completely free. You are not using it properly, isn't it? So if you make two, both will execute parallelly. If you make it a 4, what happens if you make it 4 is these two cores first execute two partitions. Once these two partitions execution is completed, it will pick the next two partitions. So both are not going to be in idle, both are going to execute again two more partitions. This is how you can optimize the execution of your Spark job. Got it? This everybody understood?
Yeah. Yes.
But one more, I mentioned if you have a two cores per core, per one core, how many partitions are recommended? 1 to 4 partitions are recommended. 1 to 4 partitions are recommended. Clear? So I will give you more examples on the partitions and all tomorrow. Okay. Till here everybody is clear. So I am just moving on to the slides. So if you move on to the slides here, if you see, so application, so in under application, multiple jobs will get created. Under jobs, stages will get created. Under stages, you can see task 1, task 2 is created, isn't it? Similarly, there are two partitions we executed in the stage 1. Similarly, stage 2 also going to create, and stage 2 again task 1 and task 2 are executed. Okay, under a single job we can have a multiple stages. Under stages we can have a task. Now we very clearly know when the new stage will get created. Whenever a Y transformation is applied, whenever a shuffling of data happens, new stage will get created. When the task will be created, task is nothing but based on the number of partitions, those many tasks will be created. Okay, those many tasks will be created. So don't confuse. It will be little bit confusing while I'm executing also, because based on the type of action you are applying, it will take the task. So I'll explain those things. Don't worry at this time. Okay. So it may create the multiple jobs as well. So job 2 again may have the stages. Under that you may have the multiple tasks. So this is the hierarchy of your application. When you submit any command, when you just execute it, it start creating the multiple jobs. Under each job it creates multiple stages. Under each stage it will have a task. On the task, one task means one partition it is executing. Clear? Got it? I'm moving on. Concept of application, job, stage, and task. What is application? A user program builds on Spark using its APIs. What are the Spark APIs? Python, Scala, R, SQL. Then what else we have? Java. We also have C#, that is .NET is supported in the Synapse. Okay. Earlier, like in the Databricks, we have only 5 languages which are supported. One is Java, Python, Scala, R, SQL. Some people will think where you are using Java sir in Databricks. No, Java is not directly supported. You can create a jar files and you can submit the Spark code. Okay, but interactive notebook supported only 4 languages, that is Python, Scala, or SQL. So application means user program builds on Spark using its API. Any API you can use to build your application code. So what happens in that application code is you are submitting that application code on the driver program. So in the driver program, basically it will connect to the executors, all those things we discussed yesterday, Spark architecture, right? You submit this particular application code on the driver program. Driver will connect to the worker nodes, that is nothing but executors, and it will execute our code. Now jobs. A job, a parallel computational consisting of a multiple task that gets kicked off in response to a Spark action. Okay, remember, so when you apply the action, then only jobs will get created. When you apply the action, then only jobs will get created. So when you are using RDDs, you can clearly see this particular concept. Okay, what the concept? When you kicked off a job, then only it basically, sorry, whenever you apply a action, in your Spark code, then only jobs will be kicked off. Now the question is, can we see same in the data frames? Data frames is little bit different, right? Data frames will do some initial checks. Anybody remember which concept we discussed? Catalyst optimizer. Anybody remember?
Yes.
Catalyst optimizer we discussed as part of our training. Okay. In the catalyst optimizer, what happens is it basically checks whether syntax is correct or not, paths are available or not, table name is available or not, and column names, whatever is specified, available or not. Everything it is going to check using the catalog. Okay, using the catalog metadata, there will be metadata there. It will go and check whether this table is existed or not, these columns are available or not, this path is existed or not. Everything it is going to check. That's why lazy evaluation we are not able to prove it using the data frame. While reading the data frame, if you just execute the read command, it will throw error if the path is not available. Okay, how it is verifying the path? Because data frames will verify the path, but if you do same thing in the RDDs, we have observed RDDs will not verify whether path is available or not. It simply, what happens is it will just execute it. When you apply action, then the transformation will execute. It will come back and try to read the data from the path, given path, but path does not existed. So what happens? You'll get immediately error saying that path not available or file not found. Okay, next. During a interactive session with the Spark shell, the driver converts your Spark application into one or more Spark jobs. You know, basically the jobs will be divided, application will be divided into one or more jobs, right? So let's not discuss more into theory. Let's focus more on the practicals. Okay. So stages, as we discussed, stages will be created whenever a shuffling of data happens, where the computation boundaries has changed. Computation boundaries. What is meant by computation boundaries? As we discussed, so first person is having 4 different types of chocolate, but when we apply group by, all the whites received by the first person, all the red is received by the second person, meaning the data that consists of the data first person is having before the transformation, after the transformation is different. When the data has changed, a new stage will get created. Task is nothing but a per partition. If you want to execute each partition, we need to create a one task. We are not going to create, automatically it will create. See here, if your data set has 2 partitions, an operation such as filter will trigger 2 tasks, one for each partition. Clear? Next. See, lazy evaluation. What is lazy evaluation? Lazy evaluation means we discussed. So there is application code you submitted on the driver node. It basically submit the code into the worker nodes, and workers has a command for read. Then basically it will just reference to the from where it has to read. Then filter transformation I am applying. So this is the filter transformation. So worker node 1 will do the filter where Krishna, where name equal to Krishna, and so out of this, which one is the transformation? Which all are the actions? Read and filter and count. There are 3 total. There are 3 things I am doing here, out of which are transformation, which are action.
Read and filter are transformations. Count is the action.
Very good. So read and filter is a transformation. Count is action. See, now what happens? You see, when I just used count, immediately start reading the records. Then it will just filter out and it tell one record. So here one record is there Krishna, here one record is there Krishna, here one record is there Krishna, and it will simply tell you result equal to 3. So when this happened, so I have basically written entire code, but until unless I apply action, the actual transformation did not execute it. Result equal to 3. Clear? Fine. So see, stage 1, only one stage get created here because there is no shuffling of data. So internal job execution, basically yesterday we have seen. Let's move on quickly into the lab. Okay. Databricks community edition login. You know, right, how to log in into the Databricks community. Basically, I just logged in. So now you see, so cluster is already available. If you want to, like, I don't want to teach from very scratch, you know already, because you all are not new to us, right? New to Databricks as well. So basically you all know already data factor Databricks course you got completed, right? So now you come here. So I'm just using this spark underscore job underscore stage underscore task. So this particular concept you will see tomorrow. So how many of you know? So first thing, how many of you don't know Databricks basics? Anybody here who has not taken Databricks training? Anybody is
Yeah,
there
Maria,
here? Just
Amish here. I just started
Amish, you are
in
in current batch. It will
Databricks.
get
Yes,
completed.
yes.
Fine. So let me tell you from very basic. Basically, yeah, Amish. Today we discussed in today's session. I just completed, right? How to upload data. So I have a CSV file. Just imagine. See here. Um, See, store location, there is a store, there are some data. I have some CSV files. Okay, so what I wanted to do with the CSV files is the CSV files I want to upload. So let me explain from very basic, then from very scratch. Okay, give me a minute, let me delete the things that are already available. Oh my god, okay, that's fine. Basically I deleted the data that is very important for us. That's okay, I'll try to reload it, but I did not remember that. Okay, we'll see what we can do. Now what you can do is basically you go here, click on data. So you see create table and browse it here, drop files to upload. Okay, just click on this and I'm going to here, just select these two files, whatever I have. Okay, what is the stores? Stores, you just copy it. Okay. Basically I'm just trying to copy these two files, select these two files and upload. Where these files get uploaded is, you can see file store slash tables. Where these files are going to upload, file store slash tables. Under file store slash tables we are uploading. You can see once the upload is completed, it can also tell you the path, file path. Okay, just wait. Okay, see, one file is already uploaded. Okay, so file store slash table slash store dot csv is uploaded. One more file is getting uploaded. Let's wait. See here, file store slash table slash store dot csv, file store dot slash table slash store locations. Okay, go to recents, click on this. Okay, these are the paths. Okay, let it be. Now what I'll do is I'll try to read the CSV files using the RDD. Okay, R1 equal to, you know, SC. What is SC?
For context.
It's very difficult for me to teach again, very basics and all.
Spark context.
Otherwise, see, what you need to do is, if you need some time, I can just wait. Okay, I'll stop taking classes for a few days. You brush up all the training recorded videos I have given to you, because this is very basics. You are not able to answer. You need to think. Okay, because without you attend n number of trainings, doesn't matter. You need to have some learning as well from your side. Okay, so text file I'm using, and I'm just trying to put this file. Okay, so execute this, no issues, very good. R1 dot collect. What is collect? Collect is nothing but action. Okay, it is kicked off. Very good. Basically data is available now. My question is, now if I say cloudpandit.csv file, and I want to just give something like this .csv file. Is this file available or not? Is this file available or not? No, it is not available. Let's execute this. You executed. Why you did not get any error? Okay,
Because
fine.
you did not call action.
I'll just do one more transformation. R2 equal to R1 dot map of something lambda x colon. Maybe you can just send as is, okay? Or if you want to do some kind of a dot upper str, I'm converting into str, and then I'm converting into upper. Let's do it. Okay, no error. Now I'm going to show R12 dot collect. Now will it throw error here or will it throw error here when I apply a collect? When I apply collect, what happens is it basically go and start reading looking at the path. When it look at the path, what is the problem here is input path does not exist, meaning this file is not available. So now you are getting the error. So from this, can I say that Spark is a lazy evaluated? Yes, Spark is lazily evaluated. The reason is unless you apply the action, transformations will not get executed. Same thing I'll try in the Spark. Okay, Spark, let's say spark dot read dot format of CSV option header equal to true dot load file store slash table slash stores dot CSV. Okay, this is fine. I'll tell you the stages, like jobs, all that concept. I'll come back. Take this dot show. So data is coming very good. Now I have given, I'm going to give same again. So this file is available or not?
Not available.
Not available. Will I get any error or not?
Yes, you will get an error.
Why I get error? Will I get error or not? See this Kondalu, go mute. Tell me why I'll get error. Because Spark data frames will have catalyst optimizer. It will do the all basic checks. So that's the reason why when the file path is not correct, immediately it will throw error unless you apply action. It will not wait for action to be triggered. It will simply check when you execute this. That time itself, it is going to verify whether this particular path is existed or not, table is existed or not. So everything is going to basically verify. Clear? Everybody's clear on this? Okay, good. Are we good till here? Good.
Yes.
Now, let's move on to jobs. How many jobs it will get created, everything. Okay. Now, what is the difference between RDD and the data frame? Even interview also very important question. What is the difference between RDD and data frame? Will RDD get the column name, data type, all those things, or only data frames will get that information? Will RDD care
only data frame will get that information?
Very good. Only data frame will look for the column names and data types, but your RDD will not look for those things. RDD will not look for those things. Okay. Now let's say if I execute this, what happens is my Spark job will go and read the first row. Will go and read the first row. Okay, clear? It will go and read the first row. Cleared all of you? So yes, let's see whether it will go and read the first row or not. We will see. Okay. Now it is going and reading the first row, meaning it is going and reading the first row, meaning we are basically reading the data or not. We are basically reading the data or not. Yes. Even though I am not applying the action, it will go and hit the file. It will try to read the one row from the file. It will not read entire data. It will read one row from the file to give you the column names, data rights. Okay, let's see, practically experience it. So now you see how many jobs are going to created? One job. Why? Because one time it is going to the file for reading a one row. It is going to the file to read a one row. That's why one. So one job is created. Under that, one stage is created. Under that stage, only one task, meaning one partition. So from this file, only one partition is executed. How many total partitions we have in this data frame? We don't know. So I'll tell you how to check it. But as of now, it just executed a one partition. Okay, now click on this job. Okay, so here what we will have is, so this is the event timeline. So what is event timeline is, it will tell you if at all any executor is, any task are getting executed, it will tell you how much time it is took for scheduling, how much time it is computed, how much time it took for generating the output, all the information it will have. This is the DAG, direct acyclic graph. It scanned the data and it generated the output. But we will see practically in detail, more detail. If you want, click on the SQL. Okay, so now what is your job ID? What is your job ID here? What is
5.
job ID? 5. So you see job ID is 5, this one only? Yes or no? Job ID 5 is this one. Just click on this. Okay, now this is the actual data it is trying to read. So in our file, lot of data is there, but what it is saying is number of files read is only one. The rows output, the output rows is, it is just read only one row. What is the size of file? Size of file is 5.6 MB. Okay, see here, file system read data size. How much data it read is 64 KB. How much time it took to read? 67 milliseconds. Metadata time to verify whether this path, the given file path is available or not, to verify that it took 1 millisecond to verify from the metadata. Okay, next, corrupted files 0, something like that. Okay, next, come here, how it is taken only one row out of those many rows is, if you see here, there is a filter clause internally, there is a filter it has applied and it has just generated one row. See, filter transformation has applied to get the only one row. That one row it is displaying, it is showing here, collect limit is 1. All of you clear? Now, next thing is, do we have any other syntax apart from this? Do we have any other syntax apart from this? Yes. Yes, right? CSV header equal to true. See, some people in interview I am seeing, very basics also they are not aware, like reading the files and all also they are not learning. Basics also, if you are not having, means nobody can help you. Okay, so learn basics. Okay, now let's execute this. What is happening? Is it changing anything if you change the syntax? No. Just click on this. Go to, again, as I mentioned, go to SQL. So what is our job ID? Job ID 6. Click on this. So you can able to see. See, you are clicking manually, going here. If you want to expand everything by default, you just select this. It will be expanded everywhere. Here, everything will be expanded. You can see a same information. Okay, clear? Next, come here, click on this. So what is the other syntax? Is there any other syntax that we have? Lot of syntaxes people are using. Okay, so you can use spark.read.format of CSV, spark.read.csv, or spark.read.load from here, comma, format equal to CSV. I am not sure whether it will work here or not in Databricks, but let's see. Yes, this is also working. Lot of syntaxes are people are using. You can use any of the syntax, but everything is same. Everything is same. Data frame is doing this. Okay, so we discussed some more options while reading the CSV file. So there is something very important options we have discussed. Anybody remember while reading CSV file, we discussed some more options, not only header equal to true, We use some more options. Anybody remember?
Infer schema, separate delimiter.
Very good. Delimiter, separator or delimiter, both are same. Infer schema equal to true. All those things we discussed. Now, what happens is when you say infer schema equal to true, what it will do? Tell me. You are already aware. I don't want to tell anything. Tell me.
It will verify the data type for few rows in the file.
It will
What is the
scan the
data type?
entire
It will
file
scan
and identify the data types of the columns.
By default, if you are not using a sampling ratio, it will go and read entire data that you have in the file to get the complete scanning, to do entire scanning. Okay, if you mention any infer schema equal to true and sampling ratio, if you say sampling ratio 0.5, meaning 50% of the records it will read to get the data types. But as we are not mentioning any such type of option, sampling ratio, what happens is first it will not know it has the infer schema equal to true. It by default read, okay, just go to the file, read one row and display. It will do it. Later it will realize, okay, there is infer schema equal to true. Okay, now I need to go back and read all the data to get a data types. So how many jobs it will create? One time is it is going and bringing with a one row that is completed. So immediately it will realize, okay, I need to do one more job. What is that? Another job. It has to read all the data to get a data type. So how many jobs are going to create in this? Two jobs. Okay, here just one row, but here two rows. Okay, let's see. See, job 8 and job 9. So there are two jobs. Why there are two tasks here? Why only one task is here? Tell me now. Shall we go and see how many partitions we have here? Okay. Can I go and see how many partitions are there here? Yes, let me show you very quickly. Very easy example I will give you. Stores 2. We also discussed as part of the training to get the number of partitions. Get num partitions. If it is not coming, I'll type it quickly. Num it came right. Num partition, type it. So it basically it has two partitions too. So that's why what happened in first job, it has just executed one partition to get a one row. But later it realized, no, I need to read entire data to get a data types. That's why 2 by 2, two partitions, entire data it is reading. That's why 2 by 2 is showing here. Got it? How many of you understood this? Let's see practically, is it correct or not? Go to SQL. So if you see here, job 8 and job 9, but here job 10 is showing. Okay, so job ID is 10 means I think 8 and 9 is combined or what? 1 second. Let's click on job 9. Okay, I think this is the latest one. You can look at here. Okay. Yeah, job is invoked once again. You just look at here. See job ID, latest job, whatever is there, that is our job. Okay. Click on that. So you see here, first you look at here, one row it has scanned. Okay. Then one row is generated in the output. 1 second, which one we have used? Let me, okay, I think I got it. So here we executed, here the job 10, job 11 got created. Okay, job 10 and job 11 got created here. So it is basically showing job 10 means this one. So why job 8 is not showing in the UI? Let's move on to the SQL. If not, let's execute once again. Okay, let's execute once again. Now what is the job number? Job number 12 and job number 13. Let's go to job number 13. Go to SQL. See, job number 12 is showing here. Okay, just click on job number 12. So job number 12, you know, it is basically getting only one row. It is basically getting only one row. That is what we expected from the job 12. Let's click on job 13. What will come when you click on job 13? Go to SQL. Why some job IDs are not showing? One second, just stage 13. Okay, see 2 by 2 tasks are executed. One second, let's execute once again. This time, let me click on the job number 15. So only job number 14 is displaying. Job number 15, it is not displaying. But you can see clearly there are 2 by 2. 2 by 2 means what? Total data. There are two partitions we have. Those two partitions, it is basically red. That's why one more job is created, and you can see clearly 2 by 2. So we also have taken the number of partitions is 2. So why it is not displaying the jobs in the Spark UI? This is the issue, but I have not seen this issue earlier. Okay, fine. You understood, right? Normally from this task, you can able to understand, isn't it? Are you clear on this? But even though, let me just try one more final way, if this works. Maybe both are same. I don't think if that is not showing there means it will show here. Both are same. See, job ID here also not showing. Completed queries. Completed queries. $37. Okay, so basically it is not taking into the UI. So we just observed the task number. We can clearly see here itself. Okay, we no need to worry about it. Basically, you can see here get num partitions is 2 we have. So in the second job, it basically reading both the tasks. Let's say if I remove this, what happens? You see, if I remove this option and execute this, you can see clearly only one job will get created and only one task will be executed, because just to get a one row. But when I mention this option info schema equal to true, it basically showing this particular problem. Okay, let it be not a problem for us, but we can able to understand very clearly that it is just reading, it's executing one partition here. Here it is executing the two partitions to get to scan all the data. Clear? Next. Here, what is this? What is this is called? What this is called?
Schema, user defined schema.
Very good. User defined schema. Why we will provide user defined schema?
For strict data types.
For strict data types. Anything else?
If we want to explicitly mention any data type we want, then.
Okay, strict data types explicitly. If you want to mention anything else, there is a lot of performance improvement. How? Your Spark job is going and scanning entire data to get a data types. Instead of that, you are simply saying, a Spark, don't scan any data, any column. I know store ID is a string type, name is a string type, store open year is integer type, store location is integer type, store owner is string type, store profit is integer type. So I am telling to the Spark, don't do anything. I am giving you all the details. Now, is there any necessity for Spark to go and read one row, or is there any necessity to Spark to go and scan entire data to get a data types or column name? Or we are providing everything? So we don't require anything. Now, how many jobs will get created?
One.
One.
Two.
Two. See, I clearly mentioned it is basically going and reading the data one row to get a column types, column names and data types. So that's why one job is getting created. In second case, it is going for the columns and getting the data types. Later, what is happening is we mentioned infer schema equal to true, means explicitly we are saying don't give the default data types. Default data types is everything it will consider as a string. Now we said scan the data and identify the data types. Don't give just blindly everything is a string. So when you use infer schema, first time even though it got the column name, second time it is going and scanning all the data to get the proper data types. Now those two things we already providing explicitly. We are telling these are the column names we have in this file, these are the data types we have in this file. So how many jobs will get created? Everything we are doing here, how many jobs will get created? No
One.
jobs.
No jobs.
Why
Sir.
jobs? Why jobs will get created? No jobs here. You see? No jobs, nothing. You no need to do anything, right? You understood? You no need to do anything. Basically, for columns, to get a columns, we are going one time. To get a data types, we are going another time. But whenever you want to go for columns, one job will get created. When you want to go for data types, it is creating one more data type, one more job. But here we are providing column names and data types both. Why it has to create any job? Nothing, not required. Okay. Now, same. So you can just do same for the store location also. You can see, as I'm just saying, give me, see, can you tell me what is the data types of this particular thing? See, D types is string and string. Basically, location ID must be integer. So now if you use infer schema equal to true, you see here what happens is here two jobs are got created. But if you ask D types, what are the D types, data types that you fetched? So D types, it is saying integer and string. How it is saying it is integer? Because it scanned the data to get a data type. Okay, one time is it scanned to get the column names. Second time it scanned to get a data types. Two jobs got created. See, Spark jobs are two here. But when it comes to here, only one job got created because it's just getting the column names. The data types, it is giving the default data type, that is string. Because string support any type of value, right? That's right. But here I'm giving column names and data types. How many jobs will get created here? None of the jobs. All of you clear? Now everybody understood how many jobs are going to create. So stages we discussed, I'll show you practically. Okay. Now, so here very carefully observe, a lot of transformations are there. This is, I'm just reading the data. So when I use this line, how many jobs will get created? Let me take this out, keep it here. How many jobs will get created if I use this? Two jobs. Okay, done. Okay, very good. Now, can you tell me how many jobs will get created when I execute this? Example, I am just commenting this line. How many jobs it is going to create now?
Two jobs.
2 jobs. See, you need to think one thing, that is, here, am I asking for anything? Can you show me the data? What is the result and all? Am I asking? No. What is the use of creating jobs, stages, everything? It will not create anything if you execute like this. Okay. So now when I use a action, it understands that it has to read this particular data, that is nothing but this data. Okay, this data it will read and it will add this column. Okay, then it will have some store location ID column. That store location ID column it will filter out. Okay, so as of now I have not displayed the columns and data types and some data in this. Let me just display that. Okay, display of here. So simple, location is having store location, store location ID, store location. Okay, something like this we have. Got it? Now, out of which what I'm saying is, I am adding a new column, derived column transformation using with column load date, current date I'm adding. So now total I will have a 3 columns. Out of 3 columns, I'm based on the store location ID, where store location is not equal to 1000. Remaining all records I'm taking and displaying. Now what happens is, when you apply action, then only it has to go and calculate everything. So when you apply action, one job will get created. One job will get created. See, only one job got created. Okay. Now let's say if I keep this line, if I keep this line here, if I keep this line here, how many jobs it will get created in this cell, in this command? 3. Very good. That's all. 2 for this line. For all these 3, only 1, because Spark is lazy evaluation, meaning all these transformation it will not execute. Why this first line is executed? Because there is a catalog, metadata information is saved for identifying paths and tables, columns, extra. So that's why it will just check only the read statements, but remaining things, all these transformation will not get executed until you trigger a action. When I trigger a action, all these like narrow transformation got executed within a same job, within a same stage, within a same one stage, one by one task is created. But if you see here, so 3 by 3, why 3 by 3? See, in store location, so 1 by 1 is here, 3 by 3 here. Why 3 by 3? Why earlier 2 by 2? 2 by 2 is for the store. Okay, that is just a store information. Here we have a 2 by 2. This is a store location. This is another table. In this table I have more records. So in this table I have more records. That's why it is created. How many jobs it got created? Sorry, how many partitions it created? 3 partitions. So 3 partitions are getting executed here. So info schema means it has to scan all the data. To scan all the data, 3 partitions it read. Now next, what is happening? Job 33, basically one row only it is displaying. Only one partition. Why only on one partition all this transformation is happening? See, in job 3 you clearly see, right? Only one by one task. Why the transformation is happening only on a one partition? Why not all the 3 partitions? Okay, I know this you may not be able to answer. The reason is you are not aware of this concept. Okay, so show, how many records show will display? Show by default it will display 20 records. 20 records it will display by default. To display only 20 records, one partition is enough. That's why it just took a one partition and executed. Now instead of show, there is a action called collect. If I use a collect, what happens is it basically read all the data. It apply the transformation on all the data. That's why in the job 3 you should be able to see 3 tasks now. See, 3 by 3. Here 3 by 3. Here 1 by 1. 1 by 1, 3 by 3, 3 by 3. Clear? All of you clear? We already getting late. I think everybody is having meetings. I am also having meetings. Okay, so this you are aware. This one we just completed here. Why repetition of code? Okay, fine. So now let's focus on the DF store one. DF store one, you remember? DF store one basically is having how many partitions? Total partitions? 2. Okay. Now let's see. Execute this. I think this is a DF store, not DF store one. DF store is also not there. Let me go and see how I created DF store 2 stores 2. Anything you can take, okay? I'm just taking DF stores 2. Execute this. So now DF stores 2 basically it has info schema, all those things is done there. Now if you see here, there are 2 jobs got created. So one job is here, one more job is here. Why there are 2 jobs? Why there are 2 jobs? Why not a single job? Okay, fine, leave it. How many stages got created here? Group by, very good. Group by is a narrow transformation or wide transformation?
Wide transformation.
So why 3 stages I am seeing? Here 1 stage I am seeing, here 2 more stages I am seeing. Okay. So what happens is when you apply a group by, basically this entire data, there are 2 partitions, right? 2 partitions. Those 2 partitions data, it will shuffle. Okay, all the store locations which belongs to one ID into one, like store location ID, all hundreds into one, all 200s into one, all 300s into one, something like that. Let's say we have 1, 10, 20, 30, 40, 50. 5 times you have. Then what happens? 10 5 times, 25 times, 35 times will be keep it in a first core. 43 times, 53 times, those things will keep it in another core. So ultimately 2 tasks means only 2 partitions we have. In partition 1 you have it 10 3 times, 23 times, 33 times. Partition 2 you have 43 times, 53 times. Okay, don't confuse, that's why. Okay, 2 by 2. Now you what you have done is the like arrangement is completed, grouping is completed. Now grouping is completed means data is moved. When the data is moved, again we need to read that particular data to get the counts and all those things. Okay, from the particular result I need to get a count. So to do the count, what it is doing is it is creating one more job. In this job, first what it is doing is it is trying to read this particular partitions data. So why this is skipped is already the data is organized, the already data is grouped. So that's why whatever you computed here, same thing it is trying to do here. That's why what we have done is we skipped this. Skipped meaning whatever you have done 2 by 2, you are trying to do same here. That's why 0 by 2 out of 2 you are trying to do 2, but we already done same operation here. 2 by 2 is completed. That's why here out of 2 we are not taking anything 0, meaning this result whatever is computed in stage 37, that result we are taking and we are calculating and displaying under stage 39. Clear? So here basically how many stages it will get created is 2 stages only. One stage is skip. The reason is the earlier whatever exchange happened, whatever grouping happened, the grouping result it is reusing. It is not recomputing again. Okay, clear? Okay. So
Yes.
fine friends, already we are late. So tomorrow we will talk about the remaining stuff. Okay. Any questions? If you have, let me know. Otherwise, we can close for today. Okay, good. Then thank you all. Thank you.